Hello students and welcome to yet another video on foundation course for business statistics. In this video we are going to quickly go through some of the solved examples. So consider this first example where we have around 15 data elements. The lowest data element is 10 and the highest value of the data element is 30. What are we expected to do? We are expected to form a frequency distribution table, and in that frequency distribution table we need to have classes which are of inclusive type, and the classes would have class interval as 4. What is the class interval? Class interval is difference between the upper limit of a class minus the lower limit of a class. That difference has to be 4. And basically inclusive type class is that class where you have upper and lower limit of that class to be included in the same class, right? And there is a gap between the upper limit of the previous class and the lower limit of the present class. Okay, so let us start forming the classes. So we can start with 10 because 10 is the lowest, and 10 plus 4 gives me 14. So my class limit, upper class limit will be 14 since the class interval is 4. Then I have to start with 15 from here because this is a inclusive class type. So 15 to 19, 20 to 24, 25 to 29, 30 to 34. So these are the 5 classes. Let us start putting the tally marks in place. My 10 will appear in this class, 17 would be in this class, 15 again is here, 22 would be in the third class, 11 is here, 16 is here, 19 again in this class, 24 is here, 29 is here, 18. So this is the fifth which I'm marking diagonal. After that is 16. Then I have 30, 25, 22 would be here, and 21 again is here. So these are my tally marks. All that I have to do is count the tally marks for each classes. So 2, 6, 4, 2, and 1. So total data elements are 15. So how do I read it? My frequency distribution, my first class has got 2 elements, second class interval 4, class 15 to 90 as 19 as 6, and so on and so forth. So let's go to next problem. Next problem, same data elements, only what is the ask? They have already given us the classes and we are asked to build a frequency distribution. But now you see that this type of class is an exclusive class, right? Because there is no gap, right? And 15 will be included in this class and not the previous class. So let's start putting 10 to 15, 15 to 20, we have 20 to 25, 25 to 30, and we'll have to put one more class which is 30 to 35 because we have an element 30 here. So we will have to put another class. So let's start adding our tally marks. First element is in the first class, second will be here, 15. Now 15 is here and not in the uppercase. Then we have 22 which is here, 11 here, 16 here, 19 here, 24 is going to be here, 29 is here, 18 I go and mark a diagonal, 16 is here, 30 is in the last class now, 25 is second last class, 22 is here, and 21 is again here. So my frequency distribution looks like this: 2, 6, 4, 2, 1. Again, it is 15. So what was the difference between first problem and this problem? It is the type of classes. In the first class, we had inclusive. In the first problem, we had inclusive. In the second problem, we have exclusive. The class interval was 4 in the first case, in the second case it's 5. Let's move on to next problem. So let's read the next problem. If the class midpoints in a frequency distribution of a age group of a group of persons is 25, 32, 39, 46, 53, and 60. So these are not data elements, but they are midpoints of frequency distribution. So what is midpoint of a frequency distribution? Typically you find midpoint in this manner. You add lower limit plus upper limit divided by 2 gives you the midpoint. Okay. What you are expected to find? You are expected to find the size of class interval, and you are expected to find the class boundaries. So let's see how a size of class intervals can be found. Size of class intervals is difference between upper and lower limits of the classes, or it is also a difference between midpoints of successive classes. So in this case, my size difference size in this case my uh, difference between midpoints of successive classes, which is size of class interval, is nothing but 32 minus 25, that is 7. 39 minus 32, and ideally this this difference needs to be same, and if you calculate, it is everywhere it's 7. So 7 is my class interval. So answer to first is 7. Now we need to find out class boundaries. So how to find out class boundaries? Okay, so one of the way to find out class boundaries is, okay, take the class interval 7 divided by 2, you will get 3.5, right? So what you need to do is, you need to, from the midpoint for the first class, for the first class, what is the midpoint? Midpoint is 25. So what I will do is, I will subtract 3.5 from 25, which will give me 21.5. Okay, and I will add 3.5 to 25, which will give me 28.5. So for the first class, my boundaries are 21.5 and 28.5. Now if you want to calculate the midpoint, as I said, it is nothing but upper limit plus lower limit divided by 2. So 21 plus 21.5 plus 28.5, that is equal to 50, divided by 2 is equal to 25. So when my 25 is the midpoint, my lower limit is 21.5, upper limit is 28.5. Similarly, what I have to do? I have to take now second midpoint, 32. So 32 minus 3.5, it is equal to 28.5, and 32 plus 3.5, that is equal to, how much it will come? 32 plus 3, 32 plus 3.5 is 35.5. So what is my class boundary for second class? It is 28.5 to 32.5. Again, if you add these two and divide it by 2, you will get 32 as a midpoint. Okay. On the similar lines, I suggest you calculate the class boundary for a midpoint having 39, for the midpoint of 46, 53, and 60. Correct? You should be able to calculate all the midpoints, all the class boundaries. Okay. So there will be 6 classes for these examples because there are 6 midpoints. Okay, so having seen this example, we'll end this video right now. Okay, thanks a lot. and wait for another video to come. Thank you.